Okay, so today we are going to write IUPAC name. Okay. Okay, so I'm just making it little zoom larger so you'll be able to write the name. Okay, the first one A. Okay, see, first we have to select the longest chain here. So here we have only this chain, so it is the longest chain for our compound, right? Okay, so now we have to write the IUPAC name. So we know our main structure that we have to follow. Someone is in waiting room. Wait a second. Samhita just joined the class. Let her join. Samhita, good evening, beta. Samhita, good evening.
Good evening, sir. Sorry, I'm late.
Okay, not an issue. You had that test, no, on Sunday?
Sir, actually, the test, sir, it wasn't working for me. Like, I clicked the link and then I didn't use it after an hour and then it stopped working.
Okay. Okay, so that test we are discussing here only.
Yes, sir.
Okay. See, we had to number the carbon atom first. So, do we have functional group? No. We have multiple bond here. That one, double bond we have between carbon and carbon atom. So, we have to identify the smallest or the minimum distance from both the end. So, from this side, this is the right side and this is the left side. So, from right side, 1, 2, 3, the third position. And from left also it is 1, 2, 3, third position. If from both the side, if it is the same, so you can count from any side. Okay, so carbon number 1, 2, 3, 4, 5 and 6. So we have 6 carbon. So what is our capsule for writing IUPAC name? We have secondary prefix plus primary prefix plus word root plus primary suffix plus secondary suffix, right? Okay, so primary prefix tells about substitution. Do we have substitution here? No, so forget about it. What about primary prefix? It tells about the cyclic nature of the compound. It is cyclic? No, so forget about it. Then word root, it tells about number of carbon atom. So how many carbon we have?
Hex.
6. So for 6 we have to write hex. Okay, then primary suffix tells about multiple bonding, and we have here multiple bonding, which is double bond, and it starts from the third carbon, so we have to write its position also 3, and for double bond I am writing ENE. Then secondary prefix tells about functional group. Do we have functional group? No, so forget about it. So this is hex 3-in is IUPAC name for the A. Easy or very easy?
Very easy, sir.
Yeah. Okay. So if your question is correct, so give 4 marks for that. Next, B1.
Yes,
B. Okay. So for that, the main chain will be this one. This is the main chain. Now we have to again number the carbon atom. So for numbering carbon atom, we have functional group is greater than multiple bonding. If functional group is not there, so we have to go for multiple bonding. Okay. So do we have the different position? We have to check from both the sides. So it is again left side. This is right side. So from right side it is 1, 2, and 3, and from left side also it is 1, 2, and 3. So both side it is same. So just don't go for that. Then we have substitution. Substitution. Do we have substitution? Yes, we have the substitution, and it is chlorine. So we have to check minimum distance from chlorine now. So it is from left side, it is on second carbon. Is it? And from right side, it is on 1, 2, 3, 4, 5th carbon. So we have to count numbers from left side only. Okay, so carbon number 1, 2, 3, 4, 5, and 6. Now we have to write substitution's name first. Okay, so 2-chloro. For chlorine it is chloro, and it is on second carbon, so we have to represent position also. So it is 2-chloro. 2-chloro. Then again the same thing. Do we have a cyclic structure? No. So forget about it. Then we have word root. Number of carbon again 6. So we had to write hex for 6. Then on third carbon, double bond we have. So it is 3 ENE. We don't have functional group, so this is the final name. So 2 chlorohex 3 ene. Easy, everyone?
Yes, sir.
Okay. Now next, option number C. Okay. Now this is going to be main chain. You can take that one also. Okay, that will be the same because we have both that methyl group. Okay, so you can take any.
Yes.
M will be the same. Okay. So again, numbering the carbon atom. So do we have functional group? No, but we have multiple bonding. Here we have the multiple bond. So we have to go minimum distance for multiple bond. So from left side, it is 1, 2, and 3. But from right side, it is 1 and 2. It starts from second carbon. So we have to count from right side only. So here we have carbon number 1, carbon number 2, carbon number 3, carbon number 4, and 5. Okay, now we have to write name for the substitution, and it is the methyl group. So its position is 2. So it is 2 methyl. Then it is not cyclic, but number of carbon we have 5. So for 5 we have to write pent. Pent. Okay. Then double bond is on second carbon, so its position is 2, and for double bond we are writing ENA. That's all. 2 methyl pent 2 in. Easy?
Yes, sir.
Samarth?
Yes, sir. Very easy.
Okay. Now here. See, double bond is here. So that side is our fix. Is going to be our main chain. Now on which side we have to move? See, in this side we don't have
In
substitution.
the upper side, there will be more carbons.
Yeah. Now don't go for more carbon now here. But here we have that substitution, no? So we have to move in that particular region. Because in this side we don't have substitution here.
Sir, we do not count the carbon substitution.
No, we had no, not like this. See, suppose we are here now. Let me erase that. Suppose we are here now, right? If we are moving in this side, so here we have 1, 2, 3. This is the fourth carbon, and here
Yes,
5, 6, and 7. So we are getting 7 here. In this side also 1, 2, 3, and 4 is 7. Again here we are on 7 only, and in this side we are on 4, 5, and 6. So longest chain we had 2 beta. These are the 2 longest chain. Now which side we have to move? So here we have that extra substitution. No, that's why we have to move in this direction. Understood?
Yes, sir.
Okay. So here, see, I have gave you already the line for that. Select the longest chain which contain functional group, then multiple bond and substitution. That chain we have to select. So here this is the main chain, and this is going to be our propyl substitution, and here for one carbon it is methyl. Okay. Yeah, methyl. Okay, so again we have to follow that capsule called secondary prefix plus primary prefix plus word root. Okay, then primary suffix and secondary suffix. Okay, so we have to start the numbering. For numbering, we are using that functional group is greater than multiple bonding and is greater than substitution. Okay, see here we have multiple bond here. So and its minimum position is from downside, right?
Yes, sir.
So we have to count from this side only. So it is carbon number 1. Okay, here we have carbon number 1. This is second, third, fourth, fifth, sixth, and seventh. And this is going to be our main chain. Okay, so see, now we had 2 substitution. One start from M and another starts from P. So M or P, which one is going to be first in alphabetical order? M. M, N, O, P. P comes later after the M, right? So we have to write name for M first, for methyl. So its position is 5. So it is 5-methyl. Oh, wait. It's 5-methyl. Then 4-propyl. 4-propyl. Then it is not cyclic, so don't go for that. Okay. Then we have word. Sorry, word root. How many carbon we have on word root? 7. So for 7, hept. Then we have multiple bonding. So it's on second. So it is 2, and for double bond we are writing ENA. That's the IUPAC name for this. Easy or very easy?
Very easy.
Was you correct, Sadab?
Yes, sir. I actually got it right.
Okay, and Samar?
I thought I messed up in the numbering, but I did it right from the bottom.
Yeah, I also did right.
Okay. Sorry. Okay, next. E. So now we are not going that much deep. I'm just writing this is our main chain, right? And we have to number from this side because we have multiple bond over here, and which is going to be minimum distance from left side. So carbon number 1, 2, 3, 4, 5, and 6. So we have to write name of substitution first. So B we have, and we have C.
5 bromo.
Yes, so
5
it is 5
bromo,
bromo.
2 chloro.
Yes, 5 bromo, 2 chloro, hex for 6 carbon. We had second position for double bond, so it is 2 ene. Easy. So 5 bromo,
Yes, sir.
2 chloro, hex, 2 ene. Easy, everyone?
Yes, sir. Yeah.
Okay, next. Now we have F. Okay, so here this side is going to be main chain, and from here that one is our main chain. Easy?
Yes, sir. Yeah.
Okay,
Yes.
so here we have carbon number 1, 2, 3, 4, 5, and 6. So here we have methyl, here we have ethyl, and here we have bromine. So bromine comes first in alphabetical order. So we have to write name first for bromine. So it is 2 bromo. This 2 bromo. Then E
4
comes
ethyl.
first. Yeah, 4 ethyl,
5 methyl, hex 2 ene.
5 methyl. Yes. Then 6 carbon, for that we have hex. Then double bond on second, so it is 2, and for double bond En. Yeah, done.
Yes, sir.
It was right also.
Yes, sir. I got everything right so far.
Okay, next. Here this is going to be our main chain.
Sir, is it supposed to be connected? I think the picture was cut off. Is it supposed to be a cyclic compound? I'm not sure if the picture is
No.
kind of...
Here cycle is not here, na. It is not one, not cyclic.
Okay.
Double bond start from first carbon here, we can say. So carbon number 1, 2, 3, 4, 5, and 6. And here we have 3 carbons, so it is propyl. Okay, and here we have chlorine. So 4 chloro. Name here will be the 4 chloro. Then 3 propyl. 3 carbon we have, 1, 2, and 3. For 3 we have propyl. Position is 3. So 3 propyl. Then substitution done. What do we have next? Cyclic. It is cyclic? No. Then number of carbon. How many we have? 6. So for 6, hex. Then we have double bond form first carbon. So directly you can write ENA. For first position, you need not have to mention the position. If you want to, you can, otherwise it is not necessary.
Sir, I have a question.
Yeah.
Let's say those two were connected and it became a cyclic compound. How would you number it?
That one. Okay, so for that, like this.
Yeah, and then there's the chlorine in it.
Okay, so now this is going to be our main chain. Okay, so we have to count from this side. So that will be our first carbon, because that substitution, that one substitution is going to close from this side. No, that's okay. So 1, 2, 3, 4, 5, and 6. So we can write name for that also. But here that substitution is the complex substitution beta, complex one, because that propyl group is substitution, and in propyl group we have chlorine as a side substitution, and position of chlorine is 1. So we have to write 1 chloropropyl. Okay, this is the name for this complex substitution. Okay, now we have to write the name.
Yeah.
Okay, so its position is 3, so we have to write 3. Then in bracket, we have to write in bracket 1 chloropropyl. Done. So square bracket close. Then after we have, it is cyclic one, so we have to use cyclo. Then how many carbon we have on cyclic structure? 6, so hex. And on first carbon we have double bond, so you can write ENA. Done.
So why
Okay,
are we
sir.
using brackets?
Because that substitution is beta complex one, complex substitution. See, here we have this carbon atom, okay, right? And here also, and here also. So this is substitution of 3 carbon. Okay, let me write here the structure for that. Here we have CH2, here also CH2, here we have CH, here we have CH, double bond, CH, here we have CH2, like this. And here in this side we have CH, here we have chlorine, here we have CH2, and here we have CH3. So this is the structure beta for that. See here in this carbon atom, okay, that one, that carbon of substitution, chlorine is present instead of hydrogen here, no? So this is going to be our main substitution, and chlorine is going to be our side substitution. So if we have main as well as side substitution, that substitution is called as complex substitution. Okay, and whenever we are going to write complex substitution, we have to use write side substitution name first, followed by main substitution, and it has to be written inside the square bracket. So this is the rule beta, which is given by IUPAC. Okay, Samhita, understood? Last day of IUPAC, I will explain that also, how to write name for complex substitution. I will make understand that. Don't worry. Okay.
Yes.
Yeah. Okay. Now H, it is remaining here. So main chain will be this. That one. 1, 2, 3, 4, 4 methyl group we have. Okay, so we had to count, check minimum position for double bond. So in this side 1, 2, 3, and 4, and in this side 1, 2, 3, 4. So from
Sir,
both the sides.
show the G question again. G question again, sir. That G bit.
Okay, wait. Done.
Yes, sir. I just have a little bit deviation. I wrote X1 in. That's
okay. It was wrong then. Your
Sir,
answer was wrong or what?
Sir, I think that's correct.
Okay, okay. So for H, we are writing the name. So this is going to be our main chain. Is it?
Yes, sir.
Yeah. So we had to start numbering. So double bond comes same distance from both the side. So we had to go for substitution. See, that side is more complex than that one, because in this side we have three methyl group. So we have to count from this side only. So first carbon, second carbon, third, fourth, fifth, sixth, seventh, and eighth carbon we have. Okay, so now we have how many carbon? No, methyl group, four methyl group. So two. See, one more thing. See, these two methyl group are present on same carbon. So we had to
Dimethyl.
no, we had to mention like all the position, individual position for each methyl group. So it is 2, 2. Then again on third carbon, so we have to write 3. Then we have again on 6 carbons, so we have to write 6. So 2, 2, 3, 6. We have 4 times. For 4 times we are using tetra. Tetra. And the name of group is methyl. Okay. So done. Next we have cyclic. No, word root we have 8. So it is oct. Okay. And for double bond we have in. So it is on second.
It is in the fourth position.
Yeah, 4. So it is 4-ENA. Yeah, this is the name for that.
Sir, I think I made a mistake. So basically what I did is, since both of them were present on 2, what I did is I said 2, 2 dimethyl, and then 3, 6 methyl. Yeah, so I did 2, 2 separately with dimethyl, and then 3, 6 separately.
No, I have that they told you if we have 1 2, if we have 1, then we don't have to use anything. If they are 2, di, for 3, tri, for 4, tetra, for 5, penta, like this.
Yes, sir, but I thought I should separate since they were on the same carbon.
No, like
okay,
this.
it's okay, now I know.
Yeah. Okay, now.
Where there is negative marking, right?
For 1 mark, minus.
Yeah, minus
okay,
1.
minus 1. Got it.
Okay, now I1. It's very easy. So see, that start from the E, and that one substitution is start from C. So C have more priority. Okay. So now we have to check from this side or this side. Chlorine is becomes close. And whenever we are counting, in cyclic structure, so all the, see, if we are starting from here, so we have to move this side. Why? Because that carbon double bond or triple bond
Yeah, the
have
double
to
must
cover.
not be covered.
Have to covered all the time. You have to remember that. Okay. So we have to check from here. So it is 1, 2, 3, 4, and 5. Then from this carbon, it is 1, 2, 3, and 4. So counting this side, chlorine becomes close, right? So we have to count from this side only. Easy?
Yes.
So it is carbon number 1, 2, 3, 4, 5, and 6. Okay.
Sir, can you once again repeat the numbering? I didn't quite get.
Okay, wait. See, whenever on cyclic compound, we are numbering the carbon atom, that double bond have to covered if we are starting from double bond then. Okay. See, so we have two position. We can start from here or we can start from here. See, that substitution start from E and chlorine start from C. So chlorine is greater than E because its position is first than the E, right? Yeah. So we had to check minimum distance from here or here for chlorine only. If we are counting from that one, so we have to move in this side because double bond is going to cover in this side. If you are starting from that, so we have to count from this side because we have to cover the double bond.
Yes, sir, got it now. Okay, thank you.
Yeah, so we have to start from here because if we are starting from here, so chlorine comes from 1, 2, 3, and 4th position. If we are starting from here, so chlorine comes on 1, 2, 3, 4, and 5 position. So that's why we have to count from that carbon atom. and we have to cover in this direction. Easy?
Yes.
Okay.
Sir, I have a doubt. How do we know if it's ethyl or methyl in the bond?
See here. Okay, here.
Yes, sir. In general, you like I'm not understanding.
Okay, you had to draw the structure for that. See, here we have carbon and have bonded 3 bonds over here, 1, 2, and 3, right? One valency is remaining. So in order to fill one valency, we have to write CH. Okay, here we have 1, here we have 1, and here we have 1. Here we have carbon and bonded 2 bonds. That one is 1 and this one is another one. So 2 valency is getting fulfilled. So here 2 is remaining. So we have to add 2 hydrogen. So it is CH2. Then here that carbon is bonding 1, 2, and 3 bond, right? So 1 is remaining. So here we will have 1H. So it is CH. Then here again CH2. Here, see here carbon is forming 1, 2, and 3 bond. So again we have CH. Double bond here also CH. And here now we have chlorine here. See, I'm writing for that one. See here again we have 2 bond for carbon, 1 and 2. So here we will have 2 valencies remaining. So CH2. And here we have CH3. So this is the structure for that beta. Okay.
Yes, sir.
Yeah. So always use. I think.
And nowadays, how do we? You always say ethyl or methyl, right? How do you identify it?
Okay. See here, if we are having 2 carbon, so the numbering. Wait a second. I have to show you that. Okay. Here we have beta methane, right? CH4. If we used to like remove one, see that is called as also alkane group, alkane, huh? And if that alk represents the number of carbon, beta, that alk represents the number of carbon. Okay, so alkane minus hydrogen, you had to minus 1 hydrogen from there, so it becomes alkyl. Okay, like for methane it becomes methyl. If we have 1 carbon, so it is methyl. If 2 carbon, ethyl. 3 carbon, propyl. 5 carbon, butyl, pentyl, hexyl, like this.
Okay, sir.
Yeah, suppose here we have methane, CH4. We have removed 1 hydrogen, so it becomes CH3. So that group is called as methyl group now. Okay, so methane becomes methyl. We have C2H6, it is ethane. If we are removing 1 hydrogen atom, so it will become C2H5. So it is, we had 2 carbon. So for 2 carbon, we are writing eth. So just use alk as a eth. So it is over here. If we replace eth here, so it will become ethyl, ETHYL, right?
Yes, sir.
Yeah. Okay, so that start from E. Okay, so we have to count number from here. So carbon number 1, 2, 3, 4, 5, and 6. So we have to write name of chlorine first, because in alphabetical order chlorine comes before then the E, and its position is 4. So it is 4-chloro. 4-chloro. For ethyl it is on 6. So it is 6-ethyl. If we have 2 carbons, so it is ethyl. Okay. Then after that it is cyclic one. So we had to use cyclo for that. Cyclo, CYCLO, cyclo. Then how many carbon on cyclic carbon chain? 6. So for 6 we have to write hex, cyclohex. And on first we had double bond, so you can directly write ENA. So 4-chloro, 6-ethyl cyclohexene, the name for I. Okay. Shamhita, understood beta?
Yes, sir.
Okay. Now here we have last but not the least, J1. Okay. So this cyclic will be our main chain. Here we have, see, 2 carbons are here, so it is ethyl group. Here we have only 1 carbon, so it is methyl group. Okay, so which one comes first, ethyl or methyl? E in alphabetical order. So we have to check minimum distance for E from these 2 positions. Okay, so obviously from this position, ethyl will be the closest on 3rd carbon, right? So we have to count in this direction now. Okay, so I'm counting the number. So it is carbon number 1, it is 2, because double bond have to cover 3, 4 and 5. Okay, so for like writing the name, we have to use write those substitution having before in alphabetical order. So 3 ethyl, 5 methyl, 5 methyl. Then it is cyclic one, so use cyclo. Then we have 5 carbons, so use pent. And from first it is starting double bond, so directly write ENA. So 3 ethyl, 5 methyl, cyclopentene.
Yes, sir.
And yeah. So
Sir,
can
you go back to G1?
Okay. G. Yeah.
Yes.
So you want to take screenshot?
No, sir. I'm actually checking. I had a question.
Here,
When we considered it to be cyclic, although it's not.
Okay. Here.
You wrote, yes, that one. So 3 dash in the square brackets, you wrote 1 dash chloropropyl, right? Do you need to include the 1?
See, again, if you want to, you can, otherwise it is not necessary. Anywhere, whether it is complex or simple.
So can you directly say 3 dash chloropropyl cyclohexene?
3 dash, where is the name? Yes. Here, no? Yeah.
Yes, sir.
This is the name for that. So if you don't use
do you
that
need
one,
the box?
Yeah, box is necessary because it is complex one.
Okay, even though the number is not there.
Yes. For
okay, got it.
For complex, you have to use square bracket always.
Yes, understood.
Okay, I am giving you one very complex example. Wait a second. For very important, everyone. Okay, so a drawing on OneNote is not good. Wait. Okay. Yeah. Okay. We have to write name for that. Okay, everyone.
Yes, sir.
Okay. It's quite complex, no?
Yeah.
Yeah.
So you start from OH. Do you go right?
Yeah, numbering. First, we have to write name for complex substitution because we have to check from where they are going to start. Okay.
Yes, sir.
Okay.
Yeah.
So see, this carbon atom which is directly attached. This is the main chain beta. Very important. Whenever we are having cyclic compound, just do consider cycle as a main chain always. So that one is the main chain. So that carbon is directly attached with the main chain, right? So that carbon is going to be first carbon always. And from there, we have to identify the longest chain. So on all the side, if we are moving, okay, we are getting like only two carbon on all the side. Here also 2, On upper side also 2, lower side also 2, right? Is it everyone?
Yes, sir.
Yeah. So now we have to write the name for that. See, these are two methyl group. Both are methyl group. So, and they are attached on 1 here. So for those we can write 1. Okay, 1. Then second is again attached on 1. So it is 1 dimethyl.
Sir, first 4 chloro will come.
We'll see. Okay, 1 dimethyl, and here we have 2 carbon. So see, these are 2 are side substitution. These are side substitution, and that substitution which is attached directly to the main chain, it is called as main substitution. Okay, so we have to write name of side substitution followed by main substitution. It is 1 dimethyl ethyl. Okay, for this again will be the same name, 1 dimethyl ethyl. So whenever, suppose if you are writing the complex substitution, just mention position for each, whether it is 1, 2, 3, whatever it may be. Okay, it is not necessary to represent 1, but from my side just use 1 position for complex. Okay, everyone.
Yes, sir. Definitely.
Okay, then we have to write name for that one. So again, this carbon is directly linked with the main chain, so this is going to be first. Then from here we have to identify the main chain, so this is going to be main chain.
Sir, I have got the answer. Should I send you on WhatsApp?
Oh, I'll check that also. So it is 1, 2, 3. So it is 2 chloro, again square bracket, 2 chloro.
2 chloropropyl.
Propyl, yes. Okay. Here it is again 2 chloropropyl. It starts from C, it starts from D, and that C also starts from C. So we can't go for this one because from here, this is the carbon number 1. From both sides, it is going to be first. Okay. So now we have to go for this side, because for this side, that chlorine, okay, comes first. Is it? So we have to
Can
go.
you repeat this part again?
See, from here, if you are writing, wait, huh? Okay. Okay. See, that chlorine, that one.
Yes.
If we start from here, carbon number 1, so 2, 3, 4, and from this side also 2, 3, 4. So we can't consider that is on minimum position. Just forget about it. But that one.
Sir, how about if there's numbers in the substitution?
No, don't go for number and all. Just go for alphabets.
Okay, got it.
Yeah. And one more important thing, See, when we are writing a name for, see, this is the main chain. Is it? And here also methyl, and here also we have methyl. So here we are considering dimethyl name. Is it?
Yes, sir.
Okay. So here that name before methyl we have di. So that D is not considered. Is not considered in case of simple substitution. Simple substitution it is not considered. But in complex substitution, if D is here, so we have to consider D is a name of the substitution. So D is a part of name in complex substitution, but not in the in simple substitution. Understood? Yes. That? So here that D is a part of the name of that compound. So D, and for that one start from C. So C will again come before the D. So we had to count from this direction. Okay, so here we have carbon OH is for 1. Here we have 2, 3, 4, 5, and 6. Okay, numbering done. Now we have to write the name. Name is very important here. for complex. Okay, so let me change the color of the ink. Okay. Again, it's hanging, I think.
Sir, why exactly did you go right side and not left?
Counting number this side?
Yes, yes.
Because that complex substitution starts from C beta. And
Okay.
that one starts from D. So C will come first. That's why.
Yes, sir. Yeah. Okay.
Yeah.
Understood.
Okay. So now we have to write the name. Okay. So first we had to write name of that one because it starts from C. And that one is also start from C. So which one we will write name first? The complex one, because complex is more have priority than simple one. If they start from both like as the same alphabet, so we have to go for complex one first because it is complex one. So complex will have more priority. Okay. Okay, everyone. Do reply.
Yes, sir.
Okay. See, here this position is 2 and here we have on 2, 3, 4, 5. Okay. So 2 and 5 are the similar. So we have to write 2, 5. See, for complex substitution, we are not using di, tri. We are using bis and tris. So I'm writing here bis. In square bracket, we have to write the name. It is 2-chloropropyl. 2-chloropropyl. Close. Then we have to write name for that C. Chloro. It is on 4th. So it is 4-chloro. Then 3 and 6. See, 3 and 6 is for 1,1-dimethyl ethyl. So 3, 6. Again, there are 2 times, so we have to write bis. We have to use bis for that. Bis. Okay. Then name 1,1-dimethyl ethyl. 1,1-dimethyl ethyl. Let me move the screen aside. Okay, 1,1-dimethyl ethyl. Like if name is done, so we have to close the bracket also. Now, name of substitution is done. Then the cyclic one, so we have to use cyclo. Rest things are like this only, cyclo. Then we have 6 carbons, so it is hex. All the carbon-carbon single bonds, we have to use AN, and instead of E, we have to use OL for alcohol group. OL. Yeah, done. So this is the name for given compound. 2,5 bis in bracket 2-chloropropyl bracket close 4-chloro, then 3,6 again bis 1,1-dimethyl ethyl cyclohexanol is the name for that compound. Easy?
Yes, sir.
You just have to follow these 5 things I have gave you, not more than that. Okay, so this is the compound and this is the IUPAC name.
So, sir, should I send you how many marks I got on WhatsApp?
Yes, yes. Aditi. Aditi. Samhita. Aditi, understood, beta?
I also send you.
Why do we write 2,5 bis?